Welcome to The Explainer. Today we are jumping into something huge: bias in artificial intelligence. How does this stuff even happen? What can we actually do about it? And maybe the biggest question of all, what does it say about us? All right, let's get into it.
So think about this. For a lot of people, this isn't some far-off sci-fi scenario. No, algorithms are already, right now, making these massive decisions in courtrooms, in who gets a job, who gets a loan. To really get a feel for what's at stake here, let's look at a real-world case.
Okay, so take a look at this. These are two real guys, both assessed by an algorithm called Compass. It's a tool used in the US to predict, well, who's likely to commit another crime. Now, on the left, you've got a black man, one prior offense, and the algorithm flags him as super high risk, a 10 out of 10. But guess what? He never reoffended. Then on the right, you've got a white man, a more serious criminal history, but the algorithm gives him a low-risk score. He went on to commit 3 more crimes.
And look, that wasn't just a fluke, a one-time mistake. When researchers really dug into the numbers, they found this really shocking pattern. The algorithm was almost twice as likely to get it wrong for black defendants, falsely flagging them as high risk. I mean, look at that, a nearly 45% error rate compared to just 23.5% for white defendants. That's huge.
So you have to understand, this wasn't some bug in the code. It's not like someone programmed it to be racist. The algorithm, well, it just learned. It learned from all this historical crime data we fed it. And that data, it was just packed with decades, even generations of human and systemic bias. So in a way, the AI was just reflecting our own world back at us. It was a mirror.
Okay, so let's get into the how. How exactly does a piece of code learn our biases? Let's break down a couple of the main ways this happens.
First up, you've got something called historical bias. And this is pretty much exactly what we saw with that Compass system. I mean, think about it. It was trained on tons of old arrests and conviction records, right? From a justice system that, let's be honest, has historically treated people of color differently. So the AI it learned those patterns. It saw them so many times that it thought, oh, this must be the objective truth, and just started replicating them.
Okay, number 2 is representation bias. This one's pretty easy to get your head around. It's when the data you use to train the AI is just lopsided. A classic example is with early facial recognition. A lot of those systems were trained on datasets that were just full of white, male faces. So what happened? Well, they were terrible at identifying women and people of color. Not because they were built to be malicious, but because they literally hadn't seen enough different faces to learn properly.
And this really gets to the core of it all, and I think this quote from Dr. Sophia Noble just nails it. It's this reminder that algorithms don't just spring out of nowhere. There are people behind them, making choices. What data do we use? What do we tell the machine is important? What problem are we even trying to solve? So yeah, AI, bias, it's not really a machine problem. It's a human problem, just written in the language of math.
All right, so if we agree this is a human problem, then what are the human solutions? Let's take a look at 3 different ideas, 3 blueprints for how we could actually try to manage AI and, build fairness in from the get-go.
Okay, this first blueprint is pretty cool. It actually borrows an idea from a totally different world: medicine. The basic concept is, what if we treated new AI systems like we treat new drugs? With that same level of caution, putting them through really strict phase testing before they ever see the light of day.
And you can see how this model lines things up perfectly between medicine and AI. So just like a drug goes through phases to check for safety and to see if it actually works, an AI would first get tested in a closed-off lab setting, then in a more open but still secure way. And this is the key part. Phase 3 involves a bias impact assessment. That's basically the AI version of checking for side effects. Then Phase 4, that's like aftermarket monitoring. Just making sure the AI is still doing what it's supposed to do once it's out in the wild.
Okay, so our second blueprint takes a different tack. It's less about outside rules and more about building a culture of responsibility inside the companies that are actually making the AI. This is the big idea from the US National Institute of Standards and Technology. You'll hear it called NIST.
So the NIST framework is all about this continuous loop. It kicks off with govern, basically setting up a whole culture around managing risk. Then companies map out all the potential problems. After that, they measure those risks, analyze them. And finally, they manage them by actually doing something about what they found. It's like an instruction manual for companies to build responsible AI from the very beginning.
All right, our third blueprint. This one's a bit more out there. It says, hey, maybe we shouldn't just rely on the government to make rules. And maybe we can't trust companies to police themselves either. So, what if we created a market for regulation?
Yeah, it sounds a little weird, but here's how it would work. The government's job changes completely. Instead of writing a bunch of detailed rules, it just sets the big goals, like self-driving cars can't have more than X error rate. Then it gives licenses to a bunch of private companies, third-party regulators, who all compete to offer the best auditing and compliance services to the AI companies. The hope is that this competition would actually make regulation better and faster, so it can keep up with the technology.
So these blueprints are all really important ideas for making AI fair. But you know what? Even if we get them perfect, they still don't answer the biggest, most fundamental question of all, which is, what are we even doing this for? What's the point of this technology?
You know, it's really easy to think of AI as this alien thing, right? A machine mind totally separate from ours. But some philosophers have a different take. They say, look, this is just the next step in a very old human story. Our intelligence has always grown alongside our tools. Think about it. The first stone axe made our hands stronger. The written word basically became our external memory. AI is just the latest tool in that long line.
But this brings up a really crucial difference in how we learn versus how a machine learns. A machine is great at finding patterns in data to solve very specific problems, which you could call a small world. Human learning? It's totally different. We learn from our messy, lived experiences in a large world full of undefined problems. We learn because we care, because we're emotionally invested, and because we have this gut feeling for what's important, an intuition built up over millions of years of evolution.
And this is where we hit on a really deep risk. The philosopher William Irwin Thompson had this warning. He said that in our race to make machines conscious, we might have to first simplify our own idea of consciousness, dumb it down into something a machine can actually copy. So the danger isn't just that our AIs will be biased. The bigger danger might be that we change, that we start to think more like machines just to get along with our own tools.
So in the end, this is the question that's on the table for all of us. This whole challenge with AI bias, it's not just a technical glitch we can fix with better code, and it's not just a regulatory puzzle we can solve with a new law. It's forcing us to look in the mirror and decide what we actually care about. What does fairness even mean? What kind of world do we want to build with these incredibly powerful tools? The answer isn't something we're going to find in a data set. It's something we have to find in ourselves.